This problem, we want to find a critical number in the open interval, critical numbers in open intervals on which function is increasing or decreasing. So we've got f of x is equal to x squared plus x plus 4 over x plus 1. Now this is going to be the quotient rule, so the top part we'll label as p, the bottom part will be q. We need p prime and q prime. The derivative of x squared plus x plus 4 is 2x plus 1. Q prime, the derivative of x plus 1 is 1. Our quotient rule is p prime q minus p q prime over q squared. So step 1, find our derivative. P prime was 2x plus 1 times q, which is x plus 1, minus p, which is x squared plus x plus 4 times q prime, which is 1, all over q squared, which is x plus 1 squared. 2x times x is 2x squared. 2x times 1 is 2x. 1 times x is 1x, or x. 1 times 1 is 1. Now this 1 at the very end doesn't do anything, but remember, if you have a negative out in front of your parentheses, flips the sign of everything inside. So the x squared becomes a negative x squared, the x becomes a negative x, and the 4 becomes a negative 4. All over x plus 1 squared. Okay, up on top we're going to combine together like terms. We got 2x squared minus x squared, that gives us x squared. We got 2x plus 1x is 3x, minus x gives us 2x. And then 1 minus 4 is negative 3. Over x plus 1 squared. Now, that's our derivative. And we're going to be plugging that in the calculator here in a minute. And the key part is, if you have more than a single number or a single variable on top or bottom, you put parentheses on it when you plug it in your calculator. So put parentheses on top. We could put parentheses around the bottom, but it's already got parentheses here. This x plus 1 to the second power is considered one item. So you don't need to have it. It doesn't hurt. Okay. Step 2. Find our critical numbers. So we'll set our, with a single fraction, you have to get a single fraction. You set your top part equal to 0. So x squared plus 2x minus 3 equal to 0. And you set your bottom part equal to 0. So I'll set x plus 1 squared equal to 0. Now this one over here factors using PSD. Reason why it's PSD is because we've got x squared x, no number in front of our x squared. This factors as x plus 3 times x minus 1. Now zero factor property. Says you get 0 on one side, you factor the other side, you're going to set each factor equal to 0. So I'll set x plus 3 equal to 0, and I'll set x minus 1 equal to 0. And we get x is equal to negative 3, and x is equal to positive 1. Now back over to this one. We got parentheses to a power equals 0. Again, you drop the power, and you just set what's inside the parentheses equal to 0. So we got x plus 1 equal to 0, and then solve that, and we get x is equal to negative 1. Let's go plug this into the calculator before we build our table of intervals. So I'm going to press my y equals, press my clear. We need our beginning parentheses on the top part. So beginning parentheses x squared plus 2x minus 3. And then I'll put a closing parentheses on the top part, divided by, and, oops, yeah, I guess there is a beginning parentheses, never mind, x plus 1. So I do x plus 1, close parentheses, and then I want squared. So I push my x squared, go away avast. Okay. Now that's how we put in our calculator. Now we will make sure we're in the correct setup for our table. So do second window. And down there at the independent, you should say ask. If it doesn't say ask, down arrow to it, right arrow, and highlight ask, and press enter one time. and then do second mode exit out. It'll stay that way from now on, so you don't have to keep redoing that. Okay, now let's build our table of intervals. Our smallest one is -3. So we have a -3. Our next one is -1. And then our next one is +1. Okay, clear over here is positive infinity. Clear over here is negative infinity. Now we want to choose our test cases. So we want to choose an x value between negative infinity and -3, like -4. We want to choose an x value between -3 and -1. -2 is a perfect choice. We want to choose a value between -1 and 1, like 0. And we want to choose one greater than 1, like 2 or 3 or whatever. Now we're going to plug those into our derivative. And now keep in mind, we just put our derivative into the y equals, didn't we? So now we can go to the table mode. So do second graph. I'm going to press delete over and over to clear out those entries I have there. And we're going to put in our test cases. So -4, enter. -2, enter. 0, enter. And 2, enter. So just put in all my test cases. Okay, the -4. When I put -4 in, I came up with a positive number, which means this is increasing. I put in -2, I came up with a negative number, so this is decreasing. I put in 0, I came up with a negative number, so this is decreasing. And I put 2 in, and it came up with a positive number, so this is increasing. Okay, so our answers. It's increasing from -infinity to -3. It's decreasing from -3 to -1. It's decreasing from -1 to 1. And then it's increasing from 1 to positive infinity. Where these numbers are coming from are the numbers are up here, they're intervals. And that would be our answer.